In this question, we know that we know the relationship between x and y is this, and we can use the relationship to draw the figure of x and y. And we also know the probability density function of random variable x and the probability distribution function of random x. And so we can use this condition to calculate the probability distribution function of random variable y. And it is obvious that the random variable y is the value of random variable y is between -1 and 2. So in the first circumstance, when y is smaller than -1, using the definition y equals to p y smaller or equals to y, and because the y is smaller than -1, so this part is obvious that it is obvious equals to 0. In the second circumstance, we found that this part is parallel to x-axis, so we need to calculate the when y is equals to -1, fy -1 equals to p y is smaller than -1, and this part equals to p y smaller or equals to -1 plus p y equals to -1. From the conclusion above, we have known this part is equals to 0, and we need to calculate this part. We can find that when y is equals to -1, x is bigger than 2, so this part's probability should equals to p x bigger than 2, and using the probability distribution function of x, we can calculate it is equals to fx2. And so this is second circumstance. In the third circumstance, when y is between -1 and 0, and this part should equals to py is smaller than -1 plus py equals to -1, and plus py is between -1 to y. And because in this when y is between -1 and 0, x is equals to negative x plus 1, so this part should equals to p -1. Oh, this should be less or equals to. And this should equals to p 1 minus y smaller or equals to x smaller than 2. And because x is a continuous random variable, so we can calculate this part using the probability distribution function of random variable x. It should equals to fx2 minus fx1 minus y. So this is so we can using this to calculate when y is between -1 and 0, fy equals to 0 plus 1 minus fx2 plus fx2 minus fx1 minus y, and this should equals to 1 minus fx1 minus y. So this is the third circumstance. In the fourth circumstance, we can also find that this part is also parallel to x-axis. So we need to calculate when y is equals to 0. y equals to p y smaller or equals to 0, which should equals to p when y is smaller than -1 plus py is equals to -1 and plus py is between -1 and 0 and plus py equals to 0. In this part we have already know in the conclusion above. This part because in this part we can using the conclusion in this part. And because the x is a continuous random variable, so we can calculate this part's probability as this. And so we also need to know the probability of py equals to 0. In the because the relationship between x and y is when y equals to 0, x is between this, so we can calculate this part. This part equals to p, and we can calculate the probability of x is between 0 and 1 equals to fx1 minus fx0, and because the x is a continuous random variable, and so in this part it should equals to 0 and plus 1. And which should equals to 1 minus fx0. In the because we have found that when y is between 0 and 2, this y is between 0 and 2, its probability distribution should parallel to y-axis. So when y is so this we didn't need to talk about we didn't need to calculate the probability distribution function between when y is between 0 and 2. We just need to calculate when y is bigger equals or bigger than 2. It is obvious that when it is obvious that this part when f y should equals to 1. So we can write the probability distribution function of random variable y as this. And we can also write it in this And so we can draw the figure of property distribution function of random variable y. Y is equals to -1. It should equals to y is equals to 0. It also should equals to 1 minus fx 0. And we can find that when y is equals to -1, it equals to 1 minus fx2. And when y is between -1 and 0, it should be a curve as this. And this point should be equals to fx1. And when x is when y is between 0 and 2, it should equals to 1 minus fx0. And when y is equals to or bigger than 2, it should be equals to 1. So this is the distribution function figure of random variable y. And using the probability distribution function, we can write the probability density function as this. Because it is obvious that when y is equals to -1, the probability distribution function of y -1 is equals to 1 minus fx2. So it is obvious that when y is equals to -1, there must be an impulse in the probability density function, and the impulse area should equals to 1 minus fx2. Thus, and when y is smaller than -1, it is obvious that the probability distribution function is equals to 0, and so the probability density function is also 0. And when y is between -1 and 0, it is the probability density function should equals to the derivative of probability distribution function, and it should equals to this. It should equals to this. And when y equals to 0, we can also find that when distribution function fy0 equals to 1 minus fx0, and there must be an impulse in the probability density function, and because the y equals to 0, the distribution function fy0 equals to 1 minus fx0. It not equals to 1 minus fx1, and so this is an impulse, and the area there's an impulse in the probability density function, and the area is x1 minus fx0. And when y is between 0 and 2, it is obvious that the probability distribution function doesn't change. So in this part, the probability density function should equals to 0. And when y is equals to 2, it is equals to 2. And because when y is equals to the distribution function of y2 equals to 1, it not equals to 1 minus fx0, and so there is also should be a impulse there, and the area should be fx0. And so when y when y is bigger than 2, it is obvious that the probability distribution function is equals to 0, and the probability density function also should be 0. And so we can draw the figure of probability density function. When y is equals to -1, there should be an impulse, and the area is equals to 1 minus fx2. And when y is equals to 0, there also should be an impulse, the area is equals to fx1 minus fx0. And when x is equals to 2, and there also should be an impulse in the area is equals to f0. And when y is between -1 and 0, and it is obvious that this part, the probability density function should equals to fx 1 minus y, should be this. So this is the figure of random variable y. And so this is the first question.